All right, calibers of handguns, guys. So here we have a chart that shows you the size of the ammunition or the bullets, which is the projectile, for handgun caliber weapons. Over here on the left side, you have the weakest. Over here on the right, you have the strongest. Now, how are these measured? Well, they're measured by the diameter of the projectile. Some of it's in millimeters, some of it is in inches. Honestly, I don't even know why, but it is. So 22 long rifle, I don't really recommend this for concealed carry. Yes, it'll definitely kill somebody, but I mean, I don't know, not really, especially with the adrenaline pumping. It won't stop them from assaulting you, at least for quite some time. 380, this is probably the smallest that I would recommend that you do carry with you. And all of these, you should have hollow point ammunition. An example of hollow point ammunition is what you see right there, where it's serrated and designed to basically fragment upon impact with the bad guy. What you see here is ball ammunition, like this one, where there is no hollow point, there is no self-defense. I mean, there is self-defense application, but you guys get what I'm saying. This has less over-penetration, so less likely to go through somebody, more likely to fragment inside of them, creating a greater cavity, a wound cavity. Also transferring more kinetic force and energy, having greater stopping power, like literally stopping power. 9mm is the most common. This is what I usually carry, and you can carry the most amount of ammo with this and have some great stopping power. 380, you're kind of limited on ammo because they're usually smaller guns and the magazines are smaller. Then you have 40, 45. 40 is a great caliber as well. You can carry a decent amount with that. Usually about 12. 45, you usually get about 7. 10, I mean, I don't even know, probably 6 or 5. I've never carried a 10mm. And then you get into these super high caliber weapons here. Now, 357, in a previous module, I said that that's like not a good concealed carry. Basically anything beyond 10mm, and even 10mm is like heavy duty for a concealed carry weapon. Up here you'll notice that the projectile is actually smaller in diameter, same with this one right here, especially compared to these guys. But what the deal is that all of this is propellant in here, and that's 5.56. That's what the military uses predominantly for most of their weapon systems. They can be configured into a handgun configuration, and so that's why they are up here as well. Why are they up here if they're so much smaller? Well, it's because of the velocity or the feet per second that projectile is traveling. That's always going to have a greater impact on what we see here called the Taylor knockout factor, TKOF. And what it is it's the grain of the bullet or the weight. They measure the weight of these projectiles in grains, as if they took a grain of wheat and put on a scale with the projectile. That's how they would weigh these projectiles, the bullets. Then we times that by the velocity, which is the speed of the bullet per second, and then also the diameter of the bullet in inches. So when we times those together and then we divide that by 7,000. 7,000, if I'm not mistaken, has something to do with joules, which is forces of energy. Then we get the Taylor knockout factor. This is the stopping power of these weapons, or of these caliber weapons. So 9mm here is at a 7, 40 is at like a 10, 45 is up here at like a 12, and so you can see that it has greater stopping power. I mean, this 357 Magnum, I'm actually kind of surprised that that's right there. 10mm is definitely the big dog on this. But you look at something like this 5.7, that was the third or the fourth largest. Yeah, that's right here. So that's the fourth largest caliber, and yet it's still all the way back here. And the reason why with this is because of the shape, the mass. It travels really fast, but the shape of it in terms of diameter, and then also the weight of it, mitigate that impact. But the speed definitely does have a great factor associated to it, because that's going to be to the 4th degree. Now you see this plus P here, 38 special plus P. This actually happened a couple days ago. I had a girl shooting a 380 and almost loaded 38 special plus P ammo, but thankfully I could feel something was not right about it, and I looked. That plus P is performance ammo, so that means that it has a special charge, gunpowder, which is why you see it's higher on that Taylor knockdown or knockout factor. is because that has more velocity. Same size caliber, 38, but this is plus P performance, so the faster that projectile travels, now the greater knockdown factor that it actually has. And so that, ladies and gentlemen, is your calibers. They measure the actual bullet, which is the projectile, in grains, as if like a little grain of wheat on a scale, and that's how they get the weight of it. They measure it in diameter, whether it's millimeters or inches, and when you see these shell casings, this is all propellant, and obviously there could be different mixtures of propellant. We're not going to talk about that in here, but faster the same caliber goes, the more damage it's going to have. Think of hitting somebody with your car at 10 miles an hour versus 50 miles an hour. Same car, same driver, same, you guys get the point. So, all right, I will see you in the next module.